Okay, let's talk angle of elevation first. Angle of elevation. What's it look like, etc. I'm only going to need 2 people here to help me out here. Literally all you have to do is hold string. You don't have to answer questions. You don't have to jump on one foot. Doesn't matter. Here you go, Kevin. Hold that for me. Natalie, want to come up? You hold that. I need you to put that at your eye level for me. And Natalie, what I need you to do is, this is going to be my horizontal line directly across. Okay, angle of elevation, kiddos. Here we go. Go ahead. Eye level. Eye level for me, okay? Angle of elevation is always formed with the horizontal and the person's line of sight. So if Kevin looks up at that snack pack putting decal up on the wall, does everyone see the angle that's being formed by his line of sight and this horizontal line? This angle right here, this angle, that's my angle of elevation. When you look, ready? As you elevation, your eyes towards an object that it is above you, you form the angle of elevation. Everybody good where this is? It always has to be formed with the horizontal and your line of sight. Okay, everybody good? He looks up even higher, this angle gets bigger. Okay, but does everyone see where it is? And most importantly, before we drop this, do you see a right triangle being formed? Okay, if I extend this out even more, then drop a vertical line down, everyone see a right triangle being formed. Okay, we good? Thanks, guys. Appreciate it. All right, so let's apply this to Scotty here. Before we draw in anything, can we just, how awesome this drawing is? Huh? How about that tree? And then the little bird on top? And then how about Scott? Huh? I'm wondering how that body of his is holding that big head up, but you never know. Okay? So his eye level, 1.5 meters above the ground. So from his eyes to the ground is up 1.5. So let's put that on the diagram first. From his eye to the ground, 1.5. Not exactly his height, but pretty close. I gotta get smaller. There we go. So 1.5 meters from his eyes. And he stands 30 meters from the tree. He is 30 meters from the tree. Got it? All right, here we go. His angle of elevation to the bird is 36 degrees. Remember the demonstration we were doing here. All right? Angle of elevation is formed from eye level and a horizontal. There's the angle of elevation. From the horizontal and your line of sight, that is 36 degrees. Everyone all right? Where to place it? Do you see a right triangle being formed now? Yes, absolutely, right here. And we're trying to find how far above the ground is the bird. So bird to ground. What's that distance there? Everyone okay with the setup where we put the numbers? Angle of elevation. Line of sight with the horizontal. All right. Can we come up with a plan? How am I going to find how high that bird is off the ground? Aman? Okay, so we're saying that if this is 30, this horizontal leg is also 30 meters. Yep. All right, but that's not going to, how am I going to find X using that triangle? Aaron? Let's find this length and then add it to what at the end? 1.5. Everyone good with our plan? Find the other leg length, add it to 1.5. We got the height of the bird to the ground. All right, this is the third day we're doing this. I'm kind of over putting little O's, H's, and A's everywhere. Can you just tell me what ratio we're using? Okay. From the 36, what's the Y? What's the 30? Get you your ratio. All right, so what ratio are you going to use here? Here we go. Let's start 10. What ratio do I want to use? Tangent, absolutely. So I'm going to say tangent of 36. You guys tell me now. What's the correct order of the ratio here? 15, what do you got? What over what? Okay, so the missing side, whatever you guys called it, I called it y. Over adjacent for everybody, that's 30. And day 3 of this now, we're solving these by cross multiplying. When you guys find this value, is that our final answer? No, and I asked that because I don't want you to do what with your calculator number? Don't round it yet. We're not ready. We're not ready to round it. So we're getting 21.7962754. That's just that one leg, and then what are we doing? Add the 1.5 now. Then we can round. Now you can round. And you guys have what on your paper? Nearest 10th? Yep. Okay, so what do you got? Nearest 10th? 24 nearest 10th? 23.3 meters. Yep. Got it. No need to change units on this one. Everyone all right? Okay, so that's looking up. Okay, my line of sight with the horizontal looking up at an object. What if I'm looking down? Okay, what if I'm on top of the building, on top of the tree, on top of a cliff, looking down at something? I don't usually do a demonstration for that. It's a little dangerous. All right, so instead, I'll just do a quick drawing. Okay, so let's say you're on top of a building looking down at something. Yep, look at this bad boy. Yep, you got it. I know what's your friend down here, and not that any of you have any, but you're looking down at your friend there, okay? This is called depression, angle of depression. You're looking down on something. Now, most people just assume that if that's my angle of elevation right here, depression's just right the other angle. No, no, because how is angle of elevation formed? Eyesight and what type of line? Horizontal. There's no horizontal line here, okay? Until I put one in. Angle of depression is looking down at something, your line of sight, and a horizontal line. So take a look. Here, right here, is your angle of depression. It's actually found not inside, but outside the triangle. Okay? It is still, it's got to be formed with the horizontal line. Okay? Looking down on an object with the horizontal line. So it's actually outside. All right? So there's depression. All right, let's go to another building. How about this diagram? Even better, huh? Yeah, look at that, huh? We really worked hard on that one. Angle of depression of 40 degrees. 40 degrees, John watches his friend approach the building while standing on a rooftop. Something's wrong here. I'm sorry, this story. Watching his friend. Does his friend know? And why are you on top of a rooftop? All right, whatever. The rooftop, 16 meters above the ground. So here's the rooftop, 16 meters. His eye level is about 1.8 from the rooftop. About 1.8. All right, ready to draw in your angle of depression now. So he is looking down to his friend. But again, not 40. Hey, not 40 in here. It's got to be formed by his, ready? His line of sight, which I just drew in as the hypotenuse, and the horizontal line. This right here is 40 degrees. Now, what are we looking for? What's the distance between John's friend and the friend building? Friend building. Got it. We're stuck. That 40 is useless to me. Why? It's got to be inside. If I want to use sine, cosine, tangent, I got to use an acute angle inside the triangle. So that 40, where it is right now, useless. Can you get one inside, though? Can you make it useful? Can you make it useful to me? Because right now, where it is, I'm not using it. There's no hypotenuse, adjacent, and opposite where that 40 is. All right, we're chirping around here. You want to tell me what we're talking about here? Okay, good talk. Yep. Talk to each other, not me. That's good start. Good start. How can I use, all right. How can I use the 40? So the angle adjacent to it is complementary to it. Yes, forms a right angle. So if that's 40, the one next to it, 50, you're not off the hook that easy though, honors kids. Is there another way I could have used the 40? Oh, use your big boy words from Unit 3. Cece, they are alternate interior. And what do you know about alternate interior? So two ways I could approach this. I could say the alternate interior angles are congruent, or what you guys said before was the angle next to it is complementary, so that had to be 50. Either way, go right ahead. So use the alternate interior angle of 40, the adjacent angle of 50. No matter which one you use, we should all be using the same ratio right now. All should be using the same ratio, no matter if you did the complementary or the alternate interior angle. 5, what one we're going to look at here? What ratio, no matter which one we use? Tangent. No matter which angle you went from, you should be using tangent. Now we may be a little different. You may be putting 40, I may be putting 50. Okay, so I'm going to use the 50 I have up here. Tangent, according to SOHCAHTOA, is opposite, which would for me to be x. Adjacent for me would be, ooh, which one you guys use? I'm not using 16, am I? I'm not using 16. I got to use 16 plus the 1.8, so yeah, 17.8. You guys that use 40, you would just have 17.8 over x instead. Okay? If you use 40, you just have 17.8 over your x. All right, cross multiply. We should all get the same value for x. And we're rounding to the nearest tenth. There's no need for sign changes or converting. 23, nearest tenth. Got it. Looking good. Anything you want to ask? Yes, Logan. We're doing, don't start 3. You're going to do that on your own in a sec. We're going to go to 4. Go.
Like, you can't make the triangle, like with the dotted line as one, or like the dash line as one of.
What do you mean, now make a triangle like this? Yeah. You could. It's the same triangle as the one we created, so you can still do it that way.
And it would be like 1040 over x.
Yeah, it still works. Yeah. Oh, any other questions? Okay, we're going to number 4 now. So 3 you'll do in a second. I know you really want to do the boat and the lighthouse, but okay, 4. I just want to do 4 with you because what did I not provide? Yeah, no diagram. We're going to have to draw our own here. Oh, and am I going to be critical? I'm going to walk around and see with these drawings. These should be good. All right. So elevation. So where are we looking? Up or down here? Up. Line of sight with the horizontal is going to be 7 degrees. And we have a control tower that's 200 feet high. Oh, everyone ready? Here we go. Go ahead. Control tower. Here we go. I don't know. Control tower. That's what I'm going. Could be a tree. I don't care. It's control tower. And that bad boy is 200 feet high. All right, now we can put the plane in because we know we're looking up at a plane at a 7-degree angle. Yep, there we go. Let's do this. Ready? Angle of elevation. Line of sight with a horizontal. There it is, 7 degrees. I see the right triangle that's being formed. There is another piece of information here. The altitude of the plane is 5,200 feet. All right, altitude, that's ground, and the plane is literally above you. Okay, so we're talking ground to the plane here. That's altitude, directly above you, 5,200 feet. Last thing is what we're looking for. What's the distance from the control tower to the airplane? Now, we could argue back and forth. Well, it's the hypotenuse or it's the leg. Okay, we could argue about this. If it does not state horizontal distance, like everyone take a look at number 3 real quick. Does everybody see it says, what is the horizontal distance? Okay, if it doesn't say that, which is the case here with our control tower airplane, it doesn't say that, we're just looking directly from control tower to airplane. Okay, if it doesn't state horizontal distance, I'm going directly from the 2 objects in between them. All right, need a little help from you guys. I'm still going to need a side length here. 22, going to need help with the side length of this right triangle. How'd you get that, young buck? 5,200 minus the 200 height of the control tower. Good. Okay, find the ratio. Here you go, 16. Which one of the 3 ratios is appropriate here? Darn right it is. Sine of 7 equals opposite 5,000 over hypotenuse. Go ahead and solve. Have some of you ever seen an airplane before? I'm wondering by your drawings. Some of you think they're looking up at a shark, not an airplane.
I think mine is pretty nice. Mine's the best. I spent a lot of time.
Let's see this bad boy. All right, all right.
Does the job.
Control towers are all represented by hammers or flashlights, it looks like on some of you. I can't, look at mine, right? Okay, here we go, 9. Nearest foot, what are we looking at, 9? Nearest foot, all right, here we go. 9? Hi, nearest foot. How far away is the control tower from the plane? Yep. What are you doing, 5,000? Yeah, yep.
Yeah, 410, 41,027.5.
What's that 0.5 do?
It goes like 2.8.
There we go. And there's no change in units, so we're good there. Okay, all good. All right, we don't have to do planes, elevation. We can also apply what we're doing to... All right, we still have to finish these two problems though before we call it a day. Going to number 5. Rhombus. That's going to eat at me all day now. We can also do sine, cosine, tangent with the rhombus, but you got to remember the properties. First of all, I can only use sine, cosine, tangent in what type of triangles? Okay, so where's that come into play when I do a rhombus? Diagonals are perpendicular, yep. All right, what else would help me here? Let's see, what else about the diagonals? They're angle bisectors, yep. And also, remember, a rhombus is a parallelogram, so what else about the diagonals? Not congruent, not congruent. Bisect each other, yep. Okay, so you have 3 and you have 5 to do right now. 3 and 5, you're not moving around anywhere. You can work with the people around you in your groups, but that's really about it. Make sure you check your answers when you're done, please. There they are right there for 3 and 5. Let's go.
Okay, AC is 80.